Welcome back to Old School Math. Let's take a look at factoring by grouping. Factoring by grouping is going to work pretty different than the last video we watched over factoring a polynomial with a leading coefficient of 1, our little quadratic there. But the first step is going to stay the same. We want to always check first for a greatest common factor in our polynomial. If there is a greatest factor, factor that out and then go from there. Now, factoring by grouping is especially useful for higher order polynomials, a cubic, a quartic, etc. with 4 terms. So if you see example 1 down here, we see that it has 1, 2, 3, 4 terms. It starts with a p cubed. So this is going to be one where we can't factor just by seeing some factors at this last number and writing it in parentheses. To factor by grouping, you're going to separate your polynomial into groups of 2 terms. And to do this, draw a line down the middle to visually separate them. You're going to factor out the greatest common factor of each side. So you are going to look for greatest common factors just on both sides here of your line that you've drawn. And then the polynomial will factor if the terms in the parentheses match. Okay, so you want to find a match in your parentheses here. And then the parentheses will act like a common factor, and that will be your first binomial. The greatest common factors from the step above will go in parentheses for the second binomial. Let's see how this works. In this first example, 10p cubed minus 5p squared plus 14p minus 7. Let's draw a line down the middle here, and I'm going to draw a little dotted line to kind of separate these two. Now, this makes things a lot easier. If you go back to your greatest common factor, we're looking for a greatest common factor here between 10p cubed and 5p squared. Well, we know 5 goes into 10 and 5, so we can put it as part of our greatest common factor. And then we have at least a p squared in both of these. So 5p squared would be our greatest common factor there. And then ask yourself, what times 5 gives you 10? That answer would be 2. What times p squared gives you p cubed? That would be a p. And notice here we've got a minus sign, so we're going to keep a minus sign right there. And then 5p squared times what gives you 5p squared? Well, the answer to that would just be 1. Okay? So the left side has been factored. We've taken out the greatest common factor of 5p squared. Let's look at this side. We've got 14p minus 7. Greatest common factor between 14 and 7 would be 7. And I'm going to write a positive 7 here. The reason I'm going to write a positive is we're going to take care of this negative in just a minute. So 7 times 2 would give you 14. And you have to keep that p. And then here, positive 7 times a negative 1 would give you a negative 7. Now the next thing the instructions said to do is to check if your binomials in parentheses matched. And they do. So we can treat it as a common factor here. We can bring this 2p minus 1 and set it in parentheses. That's part of it. And the next part of it would be 5p squared plus 7. So in that second parentheses, you're just going to grab this stuff that was in front of each set of binomials there. So you're going to find the greatest common factors and you're going to put them together in parentheses. Be careful with your signs in these. In this next one, we've got 21m cubed minus 56m squared minus 6m plus 16. Now, if we're looking for a greatest common factor on this one, we don't see every term having an m in it, so there's no variable in it. Let's check 21. So we know that 1 and 21, it doesn't divide by 2, but it can divide by 3 and 7. 56, that would be 8 times 7. So 7 might be a greatest common factor, but then we look at this term and we see, well, it doesn't divide by 7. 16 doesn't, so we don't have a greatest common factor here. Let's go ahead and divide this down the middle. Let's find the greatest common factor for the left-hand side. So we said that 7 was a common factor between 21 and 56. And the lowest number of m's that they both have in common is 2. So 7m squared. 7 times 3 will give you 21. M squared times m will give you m cubed. 7 times 8 is 56, so that'd be minus 8. And we don't have another m to multiply. M squared times 8 would give you 8m squared, or 7 times 8 would give you 56. So we're done with that step. Let's check this part out here. Now, since this is a negative, I'm going to pull out a negative to start with. And we'll make sure that that makes the signs match. If that doesn't make the signs match, all we need to do on the right side is just go back and change all of our signs. So we know that 6 and 16 both have a 2 in common, and they don't have any variables in common because the 16 doesn't have an m with it. So we could say that would be 3m Negative 2 times 3m would give us negative 6m. And negative 2 times times a negative 8 would give us positive 16. The negative times negative gives us a positive. Our parentheses match, so that's our first binomial here, 3m minus 8. And then in the second binomial, we'd have 7m squared minus 2. And we are done. On this next one, all right, we've got an even number, even number, even number, odd number. We can't take out 2. 35 isn't divisible by 3. I don't think we have the greatest common factor on this one either. So let's divide it. What do 56 and 35 have in common? We said above 8 times 7 is 56. 5 times 7 is 35. So 7 could be a greatest common factor, and they both have an n squared. So we'd have an 8n and then minus 5. On this side, 16 and 10, you'd have a 2 in common. 2 times 8 would give you 16, and we'd need to leave the n in there. So when we do 2 times 8n, we'd get 16n. And then 2 times negative 5 would give you negative 10. The parentheses match, so we could say that's 8n minus 5. And our other parenthesis here, the 7n squared plus 2. Again, it doesn't matter which order you put the parentheses in, just that the things in the parentheses are all there. Let's look at our last example. Since 5 is prime and 7 is prime, I know there's not a greatest common factor in this whole problem. So we could look at 25 and 35. We would know that they are both divisible by 5. And we'd have a k squared, because that's the least number of k's that they both have. So 5 times 5 would give us 25. K squared times k would give us k cubed. 5 times a negative 7 would give us negative 35. K squared times nothing would give us k squared. So, or times 1, I guess. So that is factored on the left side. Let's look at the right side. Now, there's no greatest common factor here, so I'm going to go ahead and write plus 1 times 5k minus 7. And I'm going to leave that plus 1 there, even though we don't necessarily need it. It's going to help us in this next step. So we check our parentheses match. So we'd have 5k minus 7 in one set. And in the other set, we'd have the 5k squared plus 1. And this is factored. Again, if you want to check that these are factored correctly, you can go back and check them with FOIL. This is a good thing to do as you're factoring, just to check that your work is correct. Thank you for watching Old School Math. I hope this video was helpful to you. If you have any questions, leave them in the comments below.